introduction to quantitative analysis, which is supposed to be like doing some analysis using quantity and all. So if we want to go structurally, we are using notebook Allen. Just go one by one. So this is our introduction. So in introduction, we got three things to discuss: mathematical tools, adaptability, and examples. So here are the mathematical tools. It's been used for thousands of years, and this is applied to a wide variety of problems. So it's not even enough to just know the basic of technique. One must understand the specific applicability of the techniques, its limitations, and its assumptions. That's more about the introduction. Now get into the examples. So I think the applicability and mathematical tools is covered. Example is telco bells. If there were 150 million using forecasting and scheduling, qualitative analysis model like their customer demand and all these things. Then television increased use by over 200 million by using quantitative analysis to develop better sales plan. And airlines saved 14 million using the model to quickly recover from the weather delays and all these options. Now, what is quantitative analysis? There is definition and factors. Definition says is a scientific approach to managerial decision making whereby raw data are processed and manipulated, resulting in meaningful information. So raw data, then quantitative analysis, then become meaningful. Also, there are quality factors like different investment alternatives, interest rates, and inventory levels. These are the factors. Also, there are weather, fertilization, state, etc. Now, which is quantitative analysis approach, and there are a couple of steps. So there are 7 steps. First is the definition of the problem, then developing a model, preparing input data, and developing a solution, testing the solution, analyzing the results, and implementing the results. We'll see this here, the same here. Now, defining the problem is clear and conscious statement. Most important and difficult step. It can be easy as well, and go beyond symptoms to true cases, and concentrate on few problems, and develop specific or measurable objects. And developing models is realistic, solvable, and understandable mathematical representation. Types of models like systemic scale, which is scope, there scale models, and schematic models, and then components. Some components, let's see, contain variables, and controllable and uncontrollable, and parameters. These are components. Controllable are determined with the decision variable, and the generally unknown parameter unknown is the controllable. Okay. What is the problem? Is it a problem? There's also a section for this. You can see variable and parameters. They are quantities, and they are controllable and uncontrollable. Querying data. They must be accurate, equal, and source. Querying data is input data must be accurate, it's the Google garbage in, then processing that and garbaging out. Data may come from a variety of sources such as company reports, company documents, and interviews, on-site direct measurements, or statistical sampling. Developing a solution, the best solutions to a problem. Okay, there's some sources you get. Just to understand the GIGO again, garbage in, processing, garbage out. The sources are company reports, interviews, on-site direct measurements, statistical sampling. Now developing the solution. We'll just find it out here. This is to find best solution by manipulating model variables. Then techniques. A couple of techniques we found: like solving equation, trial error, complete enumeration, and using an algorithm. Let's see this. The best solution to a problem is found by manipulating model variables until a solution is found that is practical and can be implemented. Common techniques are solving equation, trial error, and trying out possible values and algorithms. Testing the solution. 3 things: test input data and model for accuracy, collect new data to test model. Results should be logical, consistent, and represent real situation. Yeah, pretty much like that. Now comes to analyzing the results. We are actually in the analysis approach on the main chapter. So we just called the couple of the steps, all the steps of quantitative analysis approach, and we're in the step which is called analyzing the result. So to determine implications of solution, implement often requires change, study and understand impact of action changes, and sensitivity analysis. And sensitivity analysis got 2 things: how results change with model or data change, and sensitivity models may choose testing. How much results of analysis change if the model input data changes. Yeah. Now implementing the results. And there are 4 things: incorporates solution into company. Can be difficult, people resisting this. Many efforts fail due to poor implementation, monitoring necessary for modifications over the time. Okay, modeling in the real world. Now we're into the advantage: developing a quantitative analysis model. Now we just can profit model example and break-even point. How to develop this modeling in the real world and quantitative analysis model are used extensively by regulators such as real problems. How to develop a quantitative analysis, this thing just getting insane. Quantitative analysis model is an important part of the quantitative analysis. Oh, I got it. This is the simple profit equation. There's a couple of things. Simply just turning the revenue into like selling price per unit into number of units sold, and also adding the fixed cost. And just like the profit model example, like revenue minus expense. Profit is like unit into like unit price minus fixed cost minus variable per unit and number of units. Parameters are this, and decision variable is x. Break-even is the same, like definition number of units for $0 profit. BEP, fixed divided by selling minus variable. Purchase time. This is example. Okay. The complete buy sells and repairs gold clock. Rebuild spring sells for $10 per unit. Okay, this is like a math thing. Easy things to skip. Now, advantage of mathematical modeling. Oh no, what did you? Okay, we are in advantage. We covered all of these things, so we don't need to just go through. Accurately represent reality, help formulate problems, give insight and information, save time and money. Only way to solve large complex problems timely and communicate problems and solutions. So there are like 6 of them. Models categorized by risk. Okay. Why I'm just selecting all of the shit. Now, copy that. So deterministic model and probabilistic model. If you see it, deterministic model and probabilistic model. What are they? I wanna know. In one line, no risk involved. All values known with certainty. And definitely this is the opposite. Involve risk, chance, uncertainty. Values are essentials based on probabilities. Computer and spreadsheet models. QM for Windows, Excel QM. I think it's there. Yeah. This is QM for Windows. And this is Excel QM. I don't need to read it. I pretty much know this. This is like decision support system for PM and QM courses, mainly of quantitative models. And Excel is like work automatically with an Excel spreadsheet, main menu, break-even problems, and goal-seek example. We're down to our last two topics. One is possible problems in quantitative analysis approach and the learning objectives. I don't think so. We need to go through this. This is our last topic. Most probably. So let's skip those. Yeah, possible problems in the quantitative analysis approach. Defining the problem, developing a model, and acquiring input data, developing a solution, testing the solution, analyzing the results. Okay. Let's get to definition of the word. What it is. Not easily identified conflicting viewpoints. We are actually reading possible problems in quantitative analysis approach, and problem definition is it's not easily identified. It might have some conflicting viewpoints and might be impact to the other departments. Beginning assumptions could be a problem again. Solution could be outdated. So we need to develop a model which can fitting textbook models and understanding the models. And then we have to input the data using accounting data and validity of the data. And to develop a solution, hard to understand mathematics, and only one answer is limited. And then testing the solution is another step. Analyzing the results, and lastly, implementation is very important. Like lack of commitment and resistance to change, and lack of commitment by quantitative analysis, it could actually like impact implementation. So we need to go to like management, fear of reuse, decision-making power. Action-oriented managers want quick and dirty techniques. Management support and user involvement are important. Yeah, you can see it here. Alright, and this is the last one. Analysts should be involved and care. Analysts should work with user and take feeling into account. So this is pretty much half of the study line. Other four actually disappeared in the first. Yeah, summary. We should actually go through this learning objective.